Alright, welcome everyone. We are going to be working on solving linear systems of linear equations using substitution. Now this should be a review for you because this information is covered in Algebra 1. So we're just going to jump right in. Now, a couple of things that we'll talk about is we'll go just review how to do it, and then we will go over cases where you do need to do it over the next 2 or 3 podcasts. So in this first one, what we're going to be doing, and let's put our title up here. And so when we use substitution to solve our systems, it's exactly what it says. You substitute or you replace one thing with another. Those of you who play sports, you understand that reference. You replace one player with someone else. So here we're going to replace one variable or expression with something else. So we're going to start off really simple. I'll be honest, I love to use substitution if it's already set up for that. And there's a couple of ways when I say I mean that. So like example 1 would be I gave you x minus, let's not do that, sorry. Let's take that off. So here's simply if I gave you x equals 2 and then the other equation is x plus y equals 3. Okay, and you just replace x. So you would have 2 plus y equals 3, and then you basically have y equals 1. And keep in mind you need to write these as ordered pairs, so it would be 2, 1. Very simple. Excuse me. Now, the next example would be where I'm not using a number, I'm using an expression. And so for this example, let's use y equals 3x, and then 2x plus y equals 15. And so what you're seeing here, excuse me, is that we're now going to replace an expression. So instead of y, we're going to write 3x. So here we have 2x plus 3x equals 15. I replaced y with 3x because I said they were equal. Now it's just a matter of combining like terms and solving for x. And so when you do that, you're going to have 5x equals 15. Divide both sides by 5, so x equals 3. Now that we know what x is, we want to take the x, plug it back into one of our two original equations to get y. I always go back to the original equation. Kind of helps with the error thing because I always try to go back to something I didn't change or didn't change very much. So I'm going to use the top one because it's easier. So I have y equals 3x. So I have y equals 3 times 3. This 3 comes from right here. So then y equals 9. So my ordered pair is 3, 9. All these answers must be written as ordered pairs. Alright. So there's another one that's pretty simple. Let's add in another slide and let's go to another example. So example 3, we're going to do, and we're just solving all of these. Keep in mind from the graphing that you've already reviewed, basically what you're looking at is where do these equations cross, okay, if they cross at all. Okay, so now this time I'm replacing y with the expression. So I'm going to have x plus x minus 1 equals 3. So that gives me 2x minus 1 equals 3. I have 2x equals 4. I added 1 to both sides here. And then divided both sides by 2, so x equals 2. Now that I know what x is, I'm going to plug it back in here, or substitute it back in. So I have y equals x minus 1, y equals 2 minus 1, y equals 1. So my ordered pair is 2, 1. Notice I continually write my answer as ordered pairs. You need to make sure you do that. Now, I'm going to go to another screen so that way I don't have to write so low. But another example, and please keep in mind, pause these whenever you need to. This is example 4, I'm pretty sure. Now here's one where they're both. So y equals 4x minus 1. And then y equals 2x minus 5. This is another prime example where it's set up for substitution because they're both set equal to y, and y is the same, so that means you can set them equal to each other. So I'm going to do 4x minus 1 equals 2x minus 5, and so I'm going to subtract 2x from both sides. There's nothing special about that, I just picked that. So there's 2x minus 1 equals negative 5. I'm going to add 1. So we're going to get 2x equals negative 4 divided by 2. And so x equals negative 2. Now I'm going to take the x equals negative 2, put it in one of the other two. It doesn't really matter. I'm going to use the second one. There's nothing special about that. So y equals 2 times negative 2 minus 5. So y equals negative 4 minus 5. Y equals negative 9. So my ordered pair is negative 2, negative 9. And guys, that's what you're doing. Now, one more instance, excuse me, that I would like to show you is when they're both in standard form. It's not set up where you have y equals. What you're looking for in that case is you want where your x or y have a coefficient of 1 or negative 1, something that's very easy to put into substitution form. So we're going to make another one here. And I'm sorry, I forgot to say quick. Okay, we're on example 5. And so an example of this, and this should all look familiar, seeing as everyone's had this from Algebra 1, and so we're just basically refreshing your memory. So here's one. We're going to have x minus 5y equals 10, and then we're going to have 2x minus 10y equals 20. Now, notice they're both written in standard form, but the coefficient of x happens to be 1. So what I'm going to do is I'm going to rewrite this so that I get x by itself. And so when I do that, I'm going to have x minus 5y equals 10. I'm just going to add 5y to both sides. So x equals 5y plus 10. You could also write x equals 10 plus 5y. Addition is a commutative property. Now I'm going to replace the x in this one with this expression. So I'm going to have 2 times 5y plus 10 minus 10y equals 20. I replace this x here with this expression because that's what we said x was equal to. Now it's just simplify and solve. So we have 10y plus 20 minus 10y equals 20. 10y minus 10y is 0, so we have 20 equals 20. Okay, we can stop right there because what you're seeing here is this is an example of a consistent system, meaning that every ordered pair works. And one of the other keys to that, if you notice, if you multiply this first equation by 2, you're going to get the second one. So this would be a mini solutions problem. Just a reminder, okay? Because there's no sense to keep doing it because it's exactly going to, every answer is going to work. Let's try another one, example 6, where every answer doesn't work, okay? So I want to do, I'm trying to find one that, hopefully, let's try this one and see if this works. I have not worked any of these out in advance, and so you're literally seeing my thinking. I'm just working these on the fly. And that's 3x plus y equals negative 23. Here, whoops, let's fix that so that it looks like negative 23 and not 23. So I'm going to get x by itself here. I'm going to add 4y to both sides. So when I do x minus 4y equals 27, I'm going to add 4y, and so we get x equals 4y plus 27. Now I'm going to do the same thing here. I'm going to replace x. Now notice you could have also used this equation and gotten y by itself and replaced y. So there's nothing special. Both of these had coefficients of a positive 1, which makes them real easy to do. So I'm going to say 3 times 4y plus 27 plus y equals negative 23. Okay, now it's just a matter of let's clean this up. And you should have a calculator out. Feel free to pause when you need to, because this is what I do. 27 times 3, that's 81. And no, I didn't know that off the top of my head. Okay, plus y equals negative 23. So I end up with 13y plus 81 equals negative 23. I did 12y plus 1y to get 13y. Now let's subtract 81 from both sides. And when you do that, you're going to get 13y equals negative 23 minus 81. And feel free to plug in the calculator if you don't know. So I have a negative 104 here. I'm going to divide both sides by 13. And I'm going to do that on the calculator. And I get that y is negative 8. Okay, now that I know y, I'm going to plug it back into one of these two. I'm going to use the second one, but you could just as easily use the first one. Doesn't matter. You know what? Let's use the first one. So x minus 4 times a negative 8 equals 27. Negative times negative is a positive, so that's x plus 32 equals 27. Subtract 32 from both sides. So 27 minus 32 should give me a negative 5. So x equals negative 5. And so what your ordered pair looks like is negative 5, negative 8. Now, keep in mind, if you remember from Algebra 1, you can always check these by taking one of the ordered pairs and substituting it back into either one of the two equations, and that works. So again, this is just a refresher, just to remind you of what substitution is like. And so in the first handout, it's all substitution, and I will look at the method to make sure you use that. You can't do something else like graphing or elimination, because I will take off for that. I'm looking to know that you know how to do a specific method. So, thank you very much, and we'll see you on the next one.